Hello everyone, in this video, we are going to see the continuation of last video. If you are not seen that video, the link is given in description, please watch the video. Okay, let we go to the video. Till the last class, we saw about what is chemical engineering, what their role in chemical industries, what are the devices used in chemical industries, how to design a devices and plants, and what are the safety measures has to be taken in industries, etc. Today we are going to see how the products are manufactured in industries in large scales. The first product we are going to see is soda ash manufacturing. Introduction. Sodium carbonate, Na2CO3, this is otherwise called as washing soda and soda ash. The properties like crystalline heptahydrate, white powder, the monohydrate. It is domestically well known as a water softener. It is manufactured from salt, coke, and limestone through the solvay process. Soda ash is the most important high tonnage, low cost, reasonably pure, soluble alkali available to the industries as well to the laboratory. Raw materials requirement. Basis, 1000 kg sodium carbonate. Salt equals 1550 kilograms. Limestone equals 1200 kilograms. Coke equals 90 kilograms. Ammonia as a catalyst equals 1.5 kilograms, loss. High pressure steam equals 1350 kilograms. Low pressure steam equals 1600 kilograms. Cooling water equals 40,000 to 60,000 kilograms. Electric power equals 210 kilowatt-hour. Now we are see how the process reaction is going to takes places. Soda ash cannot be get by direct reaction, it undergoes a series of steps. They are: first, raw material limestone, otherwise called as calcium carbonate, is decomposed into calcium oxide and carbon dioxide. The energy released during this reaction is plus 43.4 kilocalories. Next, the coke is reacted to oxygen to form carbon dioxide. The energy released during the reaction is minus 96.5 kilocalories. And then calcium oxide is reacted with water and forms a calcium hydroxide, otherwise called as slaked lime. The energy released during the reaction is minus 15.9 kilocalories. And ammonia is reacted with water to form ammonium hydroxide. The energy released during the reaction is minus 8.4 kilocalories. And 2 moles of ammonium hydroxide is reacted with carbon dioxide to form ammonium carbonate and water. The energy released during the reaction is minus 22.1 kilocalories. Again, ammonium carbonate is reacted with carbon dioxide and water to form 2 moles of ammonium bicarbonate. And Ammonium bicarbonate is reacted with sodium chloride to form ammonium chloride and sodium bicarbonate. And then 2 moles of sodium bicarbonate is decomposed into sodium carbonate, carbon dioxide and water. The energy released during the reaction is plus 30.7 kilocalories. Here itself we got our final product. The next reaction is going to be recovery of ammonia from ammonium chloride. 2 moles of ammonium chloride is reacted with calcium hydroxide to form ammonia, calcium chloride, and hydrogen. The energy released during the reaction is plus 10.7 kilocalories. The positive sign indicates the endothermic reaction and negative sign indicates the exothermic reactions. Solvay process. This process uses sodium chloride to provide the sodium ions and calcium carbonate for the carbonate ions in sodium carbonate. Salt and limestone are cheap and plentiful raw materials. Unfortunately, salt and limestone do not react together. The key reaction is that between sodium chloride solution and carbon dioxide in the presence of ammonia. Overall process. Ammonia is dissolved in a salt solution and ammoniated brine solution is allowed to react with CO2, which is obtained by calcining limestone with coke. A precipitate of NaHCO3, thus obtained, is then calcined to produce high purity Na2CO3. Now we are going to see about block flow diagram, how the process is going to carry out. This process named Solvay process. First, limestone or calcium carbonate is passing into the lime kiln. Here limestone is decomposed into calcium oxide and carbon dioxide. And then calcium oxide is reacted with water, forms into calcium hydroxide. And then, in ammoniating tower, ammonia is reacted with brine, water, and sodium chloride to form ammoniated brine. And ammoniated brine is passed into carbonating tower. Here sodium chloride, ammonia, water, and carbon dioxide, which is formed as byproduct in lime kiln, is reacted to form sodium bicarbonate and ammonium chloride. Now the sodium bicarbonate is filtered and dried, and formed as sodium carbonate, and CO2 is recycled to carbonating tower. Now the ammonium chloride is sent to ammonia recovery tank along with calcium hydroxide, and then ammonia is formed and it is sent back to ammonia tank. Here we get calcium chloride as a byproduct. Next we are going to see about process flow diagram. Whatever the explanation I gave on block flow diagram is same for process flow diagram. Solvay process, steps involved. Preparation and purification of brine. Ammoniation of brine. Carbon dioxide formation. Carbonation of ammonium brine. Major engineering problem. Absorption units. The absorption units should be constructed to permit the downward travel of growing sodium bicarbonate crystals. This is done by having each unit simulate a very large single bubble cap with down-sloping floors. Making tower. Sodium bicarbonate formed in the making tower is drawn off as a suspension. It is necessary to ensure that the precipitated sodium bicarbonate is easily filterable and efficiently washable. Development of suitable calcining equipment. Moist sodium bicarbonate will cake on sides of kiln, preventing effective heat transfer through shell. Filtration unit. Filtration should be carried out by using vacuum on the drum filter. It helps in drying the bicarbonate and in recovering ammonia. Ammonia recovery. Ammonia recovery costs 4 to 5 times that of Na2CO3 inventory, so losses must be kept low. Waste disposal. Large quantities of CaCl2NaCl liquor is generated during the process. The uses of these liquor is to be find out or dispose it as waste. Major equipments used in this industries are rotary kiln, absorption tower, rotary drum, modified process. The principal modification is recovery of NH4Cl. Liquor from bicarbonate filter is mixed with washed salt feed to aid precipitation of NH4Cl, which is crystallized in a refrigerated tank at 0 degrees Celsius. The slurry is centrifuged and NH4 crystals are dried in a rotary drum hot air dryer and packaged. Engineering problems. Salt purification. Corrosion. Refrigeration. Advantages and disadvantages. Advantages of Solvay. Can use low-grade salt. Less electric power. Less corrosion problems. No co-products to dispose of. Does not require ammonia plant investment. Disadvantages. Higher salt consumption. Higher investments in NH3 recovery units. Waste disposal of CaCl2 brine stream. More steam consumption. Higher capacity plant for economic break-even operation. NH4Cl can be used as mixed chemical fertilizer ingredient. That's all about the video. We see in next video with elaborate information. Thank you for watching this video. If you are new to my channel, subscribe my channel and press the bell icon.